there, we're going to talk today about Manitoba Hydro. Manitoba Hydro is a crown corporation, so that means that it's owned by the Manitoba government, and it's Manitoba's major energy utility. So almost all the electricity that we use in the province of Manitoba is from self-renewing water power. So delivering electricity produced at generating stations occurs in 3 stages. So basically what happens is we have some hydroelectric dams in northern Manitoba. So those have huge high voltage lines. So if you've ever seen the kind of the telephone or the, not telephone poles, but the electricity poles, the hydro poles that are the big kind of square metal poles, the ones that are really, really wide, those are high voltage line systems, and they carry the electricity from the generating systems in northern Manitoba down to southern Manitoba in the terminal stations. So they all come into Manitoba Hydro, which is on Victoria Avenue East in Brandon. So they come to those terminal stations in southern Manitoba where they're converted into lower voltages. So then sub-transmission lines feed the electricity into distribution systems where voltages again are converted to lower levels. So there's distribution systems all over the city. So there's one at 18th Street. Victoria, kind of just by Hydro by 18th Street. Is it 18th Street East there? There's some there. There used to be one at kind of like 34th and Elvis Crescent, but some of them in the recent years have been dismantled, and they've got newer technology that makes them a lot smaller. And lastly, the final conversion occurs at the pole top or underground transformers, which provides either that 120 volt or 240 volt services at customers' homes. So 120 volts are basically what most of your household plugs are. There are a couple of appliances in your house that need a different plug or outlet. So if you've ever looked behind your oven or your dryer, it would have a big round plug, and that's a 240 volt service. So most plugs, again, all the standard ones that you plug your phone into charge or whatever else are 120 volt plugs, but usually people have about 2 in their home that are those 240 volt. So there's 3 lines that enter a house. So there's a 120 volt red wire, a negative 120 volt black wire, and a neutral white or bare wire. So all the wires are very dangerous. So you should never kind of do your own be your own electrician. They should only be inspected or worked on by qualified electricians. So household circuits are in parallel. So recall that the circuits, we didn't do the circuits lab this year, unfortunately, but we found out that if we had done it, we would have discovered that parallel circuits have the same voltage. So this permits more than one appliance to be plugged in to the same line. But if you add more devices in parallel, you have a higher need for current. So the more current you need. The more current means the more energy in the wire, and the wire can heat up. So we use circuit breakers, which turn off the power if the current exceeds a safe value. I'm going to just talk about circuit. So we used to call them fuse boxes, but most houses somewhere, usually in the basement or the utility room, have like a gray circuit breaker box. So and this used to happen, I have 2 older sisters, so if we all tried to kind of go out to supper or something at the same time and we were blow drying our hair, the plugs that we all used were on the same circuit, so we would often blow the circuit breaker. So what you'd had to do is you'd have to unplug the appliances that were plugged in, go down to that circuit breaker box and find the breaker that was flipped to the other side and then reset it. Obviously, once that happens, though, you all can't plug the same blow dryers or the same appliances in to the same thing. Somebody's got to go either wait or go to a different circuit. They used to have fuse boxes, so fuses would blow. It would do the same thing. The fuse would go if the current exceeded a safe value. The difference with the fuse box was you actually had to have extra fuses on hand. So there was kind of like a light bulb. If your fuse blew, you actually had to unscrew that fuse and put a new one in. So if your fuse for your oven blew on a holiday and you didn't have a backup or a spare, you would be in trouble that your oven or whatever wouldn't work until you got into a hardware store to get a new fuse. So circuit breakers are a little bit more convenient because you can just flip the switch and reset them. They still provide that safety net if the current exceeds a safe value. Household appliances. So most appliances in your house, like your hair dryers, toasters, are just various types of resistances or resistors that give off heat. They're built to work in a specific voltage and current range, which is stated on the back of the appliance usually. They'll all take the path of least resistance. So if you're using something and the cord gets damaged, that path of least resistance may actually be your body. So you might get a shock. So you need to be careful when using appliances because that shock could be lethal. So if you have anything with a damaged cord, you should really discard that and get a new one. When we're talking about power supplied to our homes, consumers, so that's the people like us that are using power in their houses, pay Manitoba Hydro for all the power that they use or consume in their homes. Since appliances use energy per unit of time, we define power as, so power is P, it's measured in watts. E is energy, measured in joules still, and time is T, measured in seconds still. So power is equal to energy, how much energy it uses, divided by the time. Sorry, my smart notebook is really unhappy today, so I apologize for the videos this week. Another way to calculate power is to say that power is equal to current, so I, times voltage. And you'll find that these are the two kind of bottom formulas on your sheet. There's one more after this. That's all for today. You can do task 7, page 28 in your book. Have a great day.